Let's look at more examples of algorithms we use every day. How would you do the following? Cross a street, bake a cake, put a shirt on, pour a glass of juice, sum two numbers of 3 digits each, or even explain to an alien how to brush his teeth. In each case, it is important to think about the assumptions that we make. For example, what assumption are we going to make for the traffic when designing an algorithm for crossing the street? Is it left hand, like in Scotland, or right hand, like in Uruguay or Spain? We need to take into account the direction of the vehicles in order to check the corresponding side. Or, let's look at a more extreme example. What assumptions can we make when teaching an alien how to brush his teeth? Does he know what a toothbrush is? And does it matter how many teeth he might have? Oh, hi there! We would like to introduce you to Cody, who's going to be participating in this course too. Cody is from a different planet. So our first challenge is to teach him how to brush his teeth. We invite you to write down your instructions, like we did in the previous examples, and upload them in the discussion forum. See you later, Cody! After analyzing a problem and making any assumptions needed, we can go ahead and describe how to do a task. We should emphasize, however, that it is crucial to clearly detail our instructions. There might be steps which mean something different for different people. For instance, if when telling someone how to bake a cake, we instruct them to put it in the oven for a short time, they wouldn't really know at what temperature the oven should be, or how long a short time really is. Now let's do an experiment that highlights the importance of precise instructions. Find a pen and a piece of paper and follow the algorithm in the following slide to draw an object. Draw a diagonal line, draw another diagonal line connected to the top of the first one, draw a vertical line over the point where the diagonal lines meet, draw a horizontal line over the straight line, draw a diagonal line from the bottom of the first diagonal to the straight line, draw a diagonal line from the bottom of the second diagonal to the straight line, draw a curvy line starting at the bottom of the straight line. What did you come up with? The original object that we were attempting to describe was a kite. Did you draw something similar? The algorithm provided was quite ambiguous, so there were many ways to interpret it. And in fact, I would expect to see a wide range of drawings, the majority of which do not resemble a kite at all. Can you write a better algorithm for drawing a kite? Have a go and test it with your friends to see if it works. Or how about developing an algorithm for drawing some other object? You can upload your algorithm in the forum and your classmates can guess what it is. As this experiment showed us, being precise is very important when giving instructions to humans. And actually, it is even more important when programming computers. All the computers do is follow instructions. So if these are not clear, computers will probably not do what we want them to. If you think about it, computers aren't really that smart. Even though they're very good at some tasks, like doing big calculations and playing chess, humans are much better in others. For example, looking after a child, recognizing objects and images, and having a meaningful conversation are not that easy for a computer. Okay, so you've learned what an algorithm is and what it looks like, and you've seen a few examples from everyday life. It's now time to start implementing algorithms in Scratch. This is exactly what we'll do in the next video.